Hey guys, welcome back to our channel Get Play Soon. In this video, we're going to discuss Quicksort, what approach it uses, how Quicksort works, how to implement Quicksort in Java, and we're also going to see how to change this unsorted array into sorted array in ascending order using Quicksort. So please stay tuned till the end. Now let's get started. What is Quicksort? Quicksort is a widely used sorting algorithm that uses divide and conquer approach. So basically in Quicksort, we have three steps: divide, conquer, and combine. Let's understand them. Take that given unsorted array and divide it with the help of pivot. Now we are supposed to divide that given unsorted array using pivot such that all the elements left side of the pivot should be less than pivot and all the elements right side of the pivot should be greater than pivot. Now for example, take number 5 as pivot. So all the elements on the left side should be less than 5, like 1, 2 or 3 or 4, and all the elements right side of the pivot, that is 5, should be greater than 5, that is 6 or 7 or 8 and so on. So that step is known as divide. And the next step is conquer. What is conquer? Once we divide the given unsorted array using pivot, we get two subarrays, the left part and the right part, that is left subarray and the right subarray. Now in the conquer, we recursively sort these two subarrays again with the quicksort method only. We do the same method again, that is called recursion. We recursively sort the left subarray and the right subarray. So that step is known as conquer. And the third step is combine. Combine is a step where we combine all the sorted subarrays, all the left sorted subarrays and the right sorted subarrays and the pivot. We combine them into a full sorted array. And this approach is known as divide and conquer approach. Now let's understand the steps how Quicksort works. Getting started with the Quicksort algorithm, the first step is to choosing a pivot. First, let's understand what is a pivot. A pivot is a value around which the array will be partitioned. So, with the help of this pivot element, we are going to divide the arrays, right? So, we are supposed to choose a pivot element. How to choose a pivot element? It can be selected at random, or you can take the leftmost element, that is the first element, or you can take the last element of the array, that is the rightmost element, or you can calculate the median and you can consider it as pivot. Now, remember, the choice of pivot can impact the algorithm's efficiency and it can be selected as anything. It's up to you. Moving ahead, the next step is partitioning. Partitioning is a process where we find the exact index of one element that we consider as pivot for the next iterations. So to do that, we will take two pointers, I and j pointers. Let's place I at the left side of the array and let's place j at the right side of the array, at the end of the array. And we keep on incrementing I until an element which is greater than or equal to pivot is encountered. And we keep decrementing j until an element less than pivot is encountered. Once we encounter that positions where we stop I and where we stop j, we will swap the elements at positions I and j. This is the process. This is how the iterations go. Now, what if I has crossed j? If I has crossed j, which meaning jth index is less than ith index, then element at first position is swapped with the element at position j, and that element will be considered as pivot for the next iterations. Don't worry, this is just an algorithm. We'll be looking at an example very clearly. So just understand the steps. That is, if I has crossed j, meaning if j's index is less than ith index, then we will swap the first position element with the element j, and that element will become the pivot for the next iterations. So this step is known as partitioning. After partitioning, what happens? We get the pivot element and then we divide the array into two parts, left subarray and the right subarray. Once we get two arrays, we do the quicksort process again for the left subarray separately, again for the right subarray separately, and again we find the pivot and the process continues recursively until we get the whole sorted array. Now don't worry, let's look at an example and understand quicksort. Now, given unsorted array is this. And let's take the first element as pivot, that is 38. And now, as we are taking the first element as pivot, let's consider the I pointer as pivot plus 1, that is I is equals to 1, that is 52. Now, let's take the jth pointer at the end of the array, that is 47. Now, you can see at the left side the swap and terminate conditions. When do we swap? When I is greater than or equal to pivot and j is less than pivot. Until we encounter these 2 points, we keep on incrementing I and we keep on decrementing j. Now, when do we terminate? When I and j cross. Now, let's start with the implementation very quickly. Now, 38 is the pivot element. Now, let's increment I pointer. Now, 58. Is 58 greater than or equal to pivot? 58 is greater than 38. So we stop I pointer there itself without moving. Now checking the jth pointer. Is 47 less than pivot? No. 47 is greater than 38. So no. So we decrement j pointer. J will be coming at 6. Now is j less than pivot? 6 less than 38. True. Now I is at a position where I is greater than pivot and j is at a position where j is less than pivot. Now swap. Once we swap, you can see 52 and 6 are swapped. 38, 6, 9, 18, 52, 47 are the now array positions. Now again iterating I and j pointers. Now I is at the second index. I is at 9. Now is I greater than or equal to pivot? No. Pivot is 38. 9 is not greater than 38. So we increment I pointer. Now is I greater than pivot? 18 is not greater than 38. We again increment I pointer. Now is I greater than pivot? 52 is greater than pivot. So we stop I pointer there. Now checking with j pointer. Is j less than pivot? Is 52 less than 38? No. Then we decrement j pointer. Is 18 less than pivot? Yes. 18 is less than pivot. Now you can see that I and j pointers cross. Jth index is less than ith index, right? So what is this condition? This condition is terminate condition. Now what are we supposed to do? We are supposed to swap the first element with the jth pointer. So 38 swap is done. Now 38 is the fixed. Now you can understand that 38 index is that particular index and all the elements to the left side of 38 are less than 38 and all the elements to the right side of the 38 are above 38. Now 38 position is fixed. Now you can see we have left subarray and the right subarray. Now let's do quicksort for the left subarray and right subarray separately. Now first start with the left subarray. Again quicksort. Taking the first element 18 as pivot, considering 6 as ith pointer, 9 as jth pointer. Now static is 6 greater than or equal to pivot? No. Incrementing I pointer. Is 9 greater than pivot? Is 9 greater than or equal to 18? No. Again incrementing I pointer. There are no elements left. So which means consider there is some memory over there and we incremented the I pointer standing at that point, that index 9. So we incremented I pointer. Now what happens? Now I and j has crossed. Jth index is less than ith index. Now swap. So what are we swapping? We are swapping the first element, that is 18, with the jth pointer. So 6 and 9 will come as a left subarray of 18 and there are no elements on the right side of 18. That's why 18 is that fixed position. There is no right subarray. We have only left subarray. 9 and 6. Again doing quicksort for 9 and 6. Consider 9 as pivot and consider I and j pointers as 6 only, at 6 only. Now starting the quicksort. Is I is greater than or equal to pivot? Is 6 is greater than or equal to pivot? No. Incrementing I pointer, you can see that j has crossed I. So j index is less than I. So it's a terminate condition. What are we supposed to do now? We are supposed to swap. Since there are only two elements, 6 comes first and 9 comes later. So you can see 6th position is fixed, 9th position is fixed, 18th position is fixed, 38th position is fixed. Now we are left with two elements, that is 52 and 47. Doing quicksort for these two elements. So consider 52 as pivot element and consider the I and j pointers as 47 itself. Now starting the quicksort. Is I greater than or equal to pivot? Is 47 greater than or equal to 52? No. So increment I pointer. So jth index is less than ith index. So swap. When there are only two elements, so swapping will be easy, 47 and 52. So this you can see now all the elements are sorted in ascending order. This is how quicksort works. The third step you already know, that is combining all the elements from all the sorted subarrays. So it is 6, 9, 18, 38, 47, 52 after the process quicksort. I hope you understood this implementation. If you have any doubts, feel free to comment below. I'll always be there to help you and solve your doubts. Moving ahead, let's understand how to code this quicksort in Java. Getting started, the code begins by importing the java.util.arrays, where we use this arrays to print the array in later part of code. Moving ahead, we have main function of the quicksort class. In the main function, we are initializing an array with the unsorted elements 38, 52, 9, 18, 6 and 47. Now once we are done with that, we are passing this array to another function, quicksort. What are we passing? Three things. The array itself, the left pointer, the left, that is the 0, as array's index starts from 0, and the right pointer, that is array dot length minus 1. Why length minus 1? Minus 1 is because the indexing starts from 0. Now once we get result from the quicksort function, we will print the sorted array. Now let's get started with the quicksort function. Here, as we already discussed earlier, we are having three parameters: one, the array itself, the low index, and the high index. Now inside the quicksort function, we have a condition. What is that? If low is less than high. So what does this mean? It checks if the low index is less than high index, which ensures that there is at least one element to sort in the current range. So consider you have only one element, and that one element has come to this quicksort function. There is nothing to sort, right? So it checks if low is less than high, which means there are multiple elements to sort. Now once we pass this if condition, we enter the if block. Inside if block, we are creating a variable pivot index to find that exact position of one element. To do that, let's go to the partition function. Again, three things are passed: array, the low index, and the high index. So as soon as we enter the quicksort, we check if the array consists of multiple elements. If it consists of multiple elements, we will go to the quicksort function, that is in the right part. Okay. And once we get the pivot element, again we divide. We come back to this quicksort function. We divide the array into left subarray and the right subarray. We recursively call this quicksort function again and again until we get all elements in sorted order. So let's understand the partition function now. In the partition function, we choose the first element as pivot, as we already saw in the example. By default, let's take the first element as pivot. And we need two pointers, that is I pointer and the j pointer. As we are already considering the first index as pivot, the low will be initialized, the I pointer will be initialized as low plus 1, and j pointer will be initialized as high, that is the last element of the array. Now we have a while loop. This while loop has a condition: I less than or equal to j. What does this mean? If you remember the example that we discussed earlier, if j crosses I, which means if j index is less than I, we stop the iteration process and we swap pivot with element j. If j is not less than I, that is if I is greater than or equal to j, we keep on checking I pointer and j pointer and we keep on doing the swapping process. And that condition is this while condition. Inside that we have if statement. It says if array of I is greater than pivot and array of j is less than pivot, then we swap array of I and array of j. When do we swap? If I is greater than pivot, if j is less than pivot, then only we swap. And inside this if condition, you know how to swap. We first store ith value in temporary variable, and then we update ith value with jth value, and then we update jth value with the temporary variable that we already saved before. Once we done swapping, we are supposed to check the next elements also, right? To do that, we will increment I pointer and we decrement jth pointer. If array of I is not greater than pivot and if array of j is not less than pivot, then we go to the else condition, where we keep on incrementing ith pointer and we keep on decrementing jth pointer by checking in every single element. And this process continues until array of I is less than or equal to j. That is the while loop condition. If jth index is less than ith index, then what we'll do? We will swap the element, the first element, that is the pivot element, with the jth value. How do we swap? Array of low, that is the pivot element, with the array of j, and array of j will become the new pivot element. Array of j will become the new pivot element. This is how the partition process is done. So once we are done with this partition process, we got that jth index as a pivot element, we got the new pivot element, then we will go back to this quicksort function. Then what happens? Then again, all the elements to the left side of the array will become left subarray. All the elements to the right side of the array, that is the right subarray. We divide as subarrays and we recursively call the quicksort function for the left subarray and for the right subarray. And again it goes to the partition function and the cycle repeats until all the elements in the array is sorted. So this is how quicksort works and quicksort implementation in Java. I hope you understood again. If you have any doubts, feel absolutely free to comment below. Now, speaking about time and space complexities. Generally, in the best and average cases, each partition step divides the array into equal subarrays, left subarray and the right subarray. So it will be like a balanced tree. You have left side array, you have right side array. So it's like a balanced tree. So the time complexity will be O of n log n. But what if the pivot element that you get after the partition process is the first element or the last element? That is the worst case scenario where pivot is the smallest or the largest element and it has only left subarray or it has only right subarray. In that case, that is the worst case, it will become unbalanced subarray. So the algorithm performance will degrade to O of n square. Hmm. So the time complexity for average and best cases is O of n log n, as I already said earlier. Now, the time complexity in the worst case scenario is O of n square. Now, speaking about space complexity. So here we are calling the quicksort function again and again when we divide the array using the pivot element, the left subarrays and the right subarrays. So the recursion depths depend on the number of recursion calls made. And in the best and average cases, the pivot will be in a balanced way. It is divide, the depth will be O of log n. But in the worst case, where it is only has the left subarray or it has only the right subarray, because the pivot might only be as the largest element or the smallest element, in that worst case, the recursion depth will be O of n. And in this partition process, we have created so many variables like pivot, I, j, etc. And all of this will be created in the constant space. So the space complexity of this algorithm is O of n in the worst case scenario. So that's it from my side. I hope you understood. I hope you liked this video. If you liked it, please like the video and share it with your friends. And please subscribe to our channel. Get placed soon.